Let's look at another binomial random variable problem. So in this scenario, we said 12 jurors are randomly selected from a population of 3 million. Of these 3 million residents, it is known that 45% are Hispanic. Of the 12 jurors selected, 2 are Hispanic. What proportion of the jury described is Hispanic? So let's see, 2 out of the 12. So 2 divided by 12. So let's see, 0.166, I'm going to just round here. So 16.67% of the jury is Hispanic. Now, 45% of the population of the residents are Hispanic, and less than 70% of this jury is Hispanic. That's a red flag right there. All right, if 12 jurors are randomly selected from a population that is 45% Hispanic, what is the probability that 2 or fewer jurors will be Hispanic? So the probability that x is less than or equal to 2. This is a cumulative probability question. So I'm going to go to my distribution menu and choose the binomial CDF. Let's see, how many trials? There are, I'm picking 12 jurors, and there's a 45% chance of picking a Hispanic juror in any one of those trials. And let's see, I'm interested in 2 or fewer, and so this is 0.0421 or 4.21%. So it's pretty unlikely, if I'm picking randomly, that I would end up with 2 or fewer when 45% of the population is Hispanic. So let's see. If you were a lawyer for a Hispanic defendant, what might you argue? I think I might argue that this jury is not representative of the community. So there are 45% of the residents are Hispanic, and only less than 17% of my jury is. And the fact that this, I could say, well, maybe that was just random, but the chance of that happening randomly are, less than 5%. It would be highly unusual. So you might argue maybe that there was the prosecutor was, hand picking or avoiding picking Hispanic jurors. So all right, so there's a very practical application of discrete or binomial probability. All right, let's look at another example. This one has to do with the side effects of a drug. So we're looking at Clarinex D. It's a medication that is supposed to reduce the symptoms associated with a variety of allergies. So in clinical trials, 5% of patients experience insomnia as a side effect. A random sample of 20 users is obtained, and the number of patients who experience insomnia is recorded. Find the probability that exactly 3 experience insomnia. We're looking for the probability that x equals 3. So this is a PDF problem because it's exactly equal. So I'll go to my distributions and find the binomial PDF. So let's see, it's a sample of 20, so those are the number of trials. There's a 5% chance, so 0.05 probability, and I'm looking for exactly 3. So that has a probability of 0.0596, so about a 6% chance that this would happen. Find the probability that 3 or fewer, so this is the probability that x is less than or equal to 3. So in this case I want the CDF, so distribution menu, CDF, we still have 20 and 0.05 and 3, and this is 0.984. Now, so notice it's a big difference, so about 98%. So exactly 3, that's fairly unlikely, but less than or equal to 3 is very likely. All right, find the probability that between 1 and 4. So think about this. What does that mean? Here's my x and p of x. 0, 1, 2, 3, 4, and 5. And those go all the way up. So I could have all 20 experiencing insomnia. So in part C, I'm looking for between 1 and 4, and this says inclusive. So this is the group that I'm looking for. Now, you could find those 4 probabilities using your PDF function and then add those up. But I want to use the fact that I can find this entire group of 0 to 4 and then just subtract off this 1. So I'm going to take the cumulative probability up to 4 and then subtract off. Now the PDF and CDF are the same for 0, so I'm going to say PDF for 0. Okay, so let's see. Distribution, binomial CDF, so 20 trials, 5% chance of success, and up to and including 4 successes. That's 0.9974, and then I want to subtract the PDF, binomial PDF, 20 trials, 0.05, and 0 successes. So I didn't actually find this, I just did the subtraction, 0.6389. I just did it all in the calculator. So there's about a 64% chance that you would have between 1 and 4. Would it be unusual to find 4 or more? 4 or more. The probability that x is greater than or equal to 4. So that's 1 minus the probability that x is less than 4, which is 1 minus the probability that x is less than or equal to 3. So in this case, I'm going to take 1 minus the cumulative probability with 20 trials, 5% chance of success, and 3, and that's 0.0159. So less than 2% chance. So is that unusual? Yes. The probability is less than 2%. Probability that x is greater than or equal to 4 is less than 2%. If 240 users of ClearNXD are randomly selected, how many would you expect to experience insomnia as a side effect? So we're looking for the expected value of a random variable. Now, for a binomial random variable, we just need to take n times p. So I have 240 users and a 5% chance that they'll experience side effects. So 240 times 0.05. I would expect 12 people in groups of 240. 12 people might experience insomnia. Now compute the standard deviation. That's sigma of x, and that's the square root of n times p times 1 minus p. So my n is 240. My p is the 0.05. 1 minus that would be 0.95. So take that product, and I need to take the square root, and that is 3.376. So in samples of 240, I expect to find around 12 people experience insomnia. But when I go from group to group, from different samples of size 240, I'm not always going to find, I may not ever find exactly 12 people who are experiencing insomnia. In fact, I expect the sample means to vary, have a typical deviation from the mean of about 3.4. This is in people would be the units there. Okay, so those are just a couple more examples. I hope this helps with your understanding of binomial probability distributions.